Alright, so let's say we want to solve this recurrence relation. So each entry of this sequence is the negative of the previous entry plus 6 of the entry before that. So what we want to do then is set up the recurrence, or sorry, set up the characteristic equation that we want to solve. So we note then we take r squared and then we add r, coefficient of 1, minus 6. And what we see here then is that yields as solutions r plus 3, r minus 2 as potential solutions to this recurrence relation. And so that gives me a sub n is equal to minus 3, c times minus 3 to the nth plus d times 2 to the nth as possible solutions to this recurrence relation. So for any choice of c or d here, that will give me a sequence which satisfies this recursion. Now, what they might not satisfy are my initial conditions here, that a sub 0 is 3 and a sub 1 is 2. So if we want to account for that, we should note that a sub 0, which is 3, is also c minus 3 to the 0 plus d 2 to the 0, which is c plus d. So we have that c plus d is 3, and similarly 2 is a1, which is c minus 3 to the 1 plus d 2 to the 1. So we get minus 3c plus 2d is 2. So this gives me a system of equations in two variables with two equations that you could solve in any number of ways. I am lazy, so I'm going to solve it in a lazy way. So I'm just going to go ahead and RREF this whole shebang here. 1, 1, 3, negative 3, 2, 2. Alright. And then REF A. And let's take a look at what the that output looks like. So it looks to me like we have a C value of 4/5 and a D value of 11/5. We could also choose to write it in its decimal form of 0.8 or 2.2. Great. So that means maybe that's easier to write. 0.8 times minus 3 to the n plus 2.2, 2 to the n looks to be the closed form to this recurrence relation. And so we, by the way, do not need to just take a word for it. This doesn't necessarily prove it, but I did write a script here in CodeCalc that will check the first 100 terms or so of a recurrence relation, both the recursion and the closed form, just to see whether or not the first 100 terms line up. So if this is the right answer, the first 100 terms really ought to line up. So let's see. Our claim is that this is 0.8 times 3, sorry, not 23, 3 to the n, and then plus 2.2, sorry, not 3, minus 3 to the n, plus 2.2 times 2 to the n, with initial values a 0, 3, and 2. And the recursion itself looks to be minus 1 times the previous term plus 6 times the term previous to that. And so if I run these, well, it's a little picky about comparing the decimal to the integer value, so that's why we also have the fractional forms, right? If I put those fractional forms in, it goes ahead, cranks out the first 100 terms for both sequences, and you can see that equality holds for every single one of these in the first 100 terms. I could set it to be the first 1,000 terms, and I don't know what we would gain from that, except a much longer output, but we can see that at least for the first 1,000 terms, they match up, and this combined with the fact that we proved that this technique to find the solutions work should convince us that yes, this is a valid way to find, or this is a valid solution to this recursion with these initial conditions. All right, thank you.